In the name of Almighty God, I'm Mahsa Sankoshi, and today I want to talk about chemical reaction engineering, measuring complex multiphysics simulation software. Now I want to go through the thermodynamics. To access the functionality of for thermodynamic calculations, right-click the global definitions node in the model builder tree and select thermodynamics. When the model includes a component, thermodynamics is also available in the physics toolbar. Using the reaction engineering or chemistry interfaces, thermodynamics is also available on the reaction engineering chemistry toolbar. Figure 6-1 illustrates the thermodynamic solvers available under the global definitions. Thermodynamic properties given as parameters or functions are collected in a so-called thermodynamic system. Each thermodynamic system includes a set of available species and phases as well as different models used for thermodynamic properties calculations. For example, an equation of state such as Peng-Robinson. Select thermodynamic system in the context menu to add a thermodynamic system that uses the built-in database included with Computer Multiphysics as an alternative. Selecting external thermodynamic system can make use of an installed thermodynamic software to make the corresponding calculations. To the option predefined system allows you to set up one of the following systems: dry air, moist air, or water steam. It is also possible to impose and import previously created and stored thermodynamic systems by selecting import thermodynamic system. Say exporting and importing thermodynamic system. In addition to creating thermodynamic systems, you can also define user-defined species in thermodynamics. Use user-defined species to add new species that are not available in COMSOL database. You can also edit available species in that database. Figure 6-2 illustrates adding thermodynamic systems to the thermodynamic node. Note that external package providers have been installed. When a thermodynamic system has been added, thermodynamic and transport properties are defined by functions. This can be used to describe properties for pure species mixtures and for gas, liquid, or liquid-liquid systems at equilibrium. Now I want to go to the thermodynamic system. The thermodynamic system is used to describe properties of pure species and mixture of chemical compounds for liquids, gases, liquid vapor equilibrium, and liquid-liquid equilibrium. It specify the available species and the phases, states of aggregation that are present in the model system. It also defines and evaluates the functions for thermodynamic and transport properties of the chemical system, that is, the species and mixture properties for liquids, gases, and phase equilibrium. To create a thermodynamic system, start the thermodynamic system wizard in one of the following ways. The first one is right-click the global definitions node, select thermodynamics, and choose thermodynamic system. The next one is using the reaction engineering interface. Choose thermodynamic system from the thermodynamics section of the reaction engineering toolbar. The third one is corresponding using the chemistry interface. Choose thermodynamic system from the thermodynamics section of the chemistry toolbar. The thermodynamic system wizard contains the following steps. The first one is select the system. The next one is select species. The next is select thermodynamics model. Now I want to go to the select system. Use the select system step in the wizard to define the phases in the model system. You can select gas, liquid, vapor, liquid, vapor, liquid, liquid, or liquid, liquid. The names of the phases in the selected system table can be changed by editing the element in the name column. Click the next button to proceed to the next step in the wizard. Figure 6-3 illustrates thermodynamic system wizard. Select system. Now I want to go to the select a species. Use the species type filter text field to search among the available species in the COMSOL database, or the user defined species can be searched for by typing the name, cast number, or the chemical formula. Using a formula, all species whose chemical formula includes a combination of the given atoms are listed. For example, when searching for ammonia, NH3 or N or H3N can be used. Select one of or more species in the list and click the Add Selected button to add a species to the selected species table. You can also press the Enter key to add either the first species in the list or the species that have been selected. To remove species from the selected species table, use either the Remove Selected button or the remove all button. Both located below the table. Click the next button to proceed to the next step in the wizard. Figure 6-4 illustrates thermodynamic system wizard. Select species. Now I want to go to the select thermodynamic model. The thermodynamic model controls and relations between the intensive thermodynamic properties of the system, such as pressure, specific volume, and temperature. It also controls high sensitive properties like enthalpy, entropy, or the heat capacity of the system are computed. Furthermore, the thermodynamic model specifies the default models used to compute transport properties. The following thermodynamic models are available for all phases: Peng Robinson, TW, Sauber Redlich-Kwang, Grabowski, Dobert. For a system including only gas phase or for liquid phase systems with thermodynamic models requiring an equation of state, the ideal gas law is added to the available models in the gas phase model list or equation of a state list. When the system includes one or more liquid phases, the following additional models are also available in the liquid phase model list, such as Chaucer, Gratian, Street, Wilson, and RTL, Unifac, VLE, Unioc, and regular solution, extended regular solution, ideal solution. These models correspond to activity models to calculate properties of water and steam. Use the water IRPWS model. This is available for systems that include a single water species. For recommendations regarding the appropriate thermodynamic model based on the available phases and the system pressure level, see the section selecting the right thermodynamic model. Select the advanced option checkbox in order to manually control the models used for thermodynamic properties, transport properties, and surface tension. When this checkbox is selected, all available property models are shown in property model table. The available property models are dependent on the phases available in the thermodynamic system. When only a gas phase is present, models are available for the following properties: gas diffusivity, gas thermal conductivity, gas viscosity, or for a single phase liquid or for two phase liquid system. There are models for the following properties: liquid diffusivity at infinite dilution, liquid thermal conductivity, liquid viscosity, liquid volume. For systems with both vapor and liquid phases, all of the above properties are available, as well as gas liquid surface tension. Figure 6-5 illustrates thermodynamic system visual advanced thermodynamic model options available for a vapor liquid system. Click the Finish button to exit the thermodynamic system wizard and add the corresponding system under the thermodynamic node. Note that the default node label reflects the available phase in the system. For example, when creating a vapor liquid system, a node label vapor liquid system is added. The name of the system can be changed using the label text field in the settings window for a system. Now I want to go through the settings section. Select the thermodynamic system or predefined system node shows its settings window with a description of the package content and the available properties. Editing the text in the label text will change the name of the system. Below follows a description of thermodynamic system settings. Figure 6-6 illustrates thermodynamic system settings, and you see that we have a property models that I wanna read it for you. Gas diffusivity, and the model is automatic. Gas liquid surface tension, the model is ideal. Gas thermal conductivity, the model is kinetic theory. Gas viscosity as a property, and the model is Broca. Gas property is liquid diffusivity, and the model is Veselink Krishna. Liquid diffusivity at infinite is property, and the model is automatic. Liquid surface tension, and the model is noun. Liquid thermal conductivity model is ideal. Liquid viscosity, the model is mass logarithmic mixing. Liquid volume, and the model is Sob Redlich Kwang. Species section. List the species included in the thermodynamic system. You can change the list of the species by right clicking the thermodynamic system node and selecting add or remove a species. Phases. List the say phases include a thermodynamic system. You can add or remove phases such as gas, liquid, or liquid vapor by right-clicking the thermodynamic system node and selecting define system. Species properties list the parameters and functions that describes thermodynamics and transport properties for pure species, such as functions may describe density, capacity, thermal conductivity, or other thermodynamic and transport properties. For more information, see a species property. Now I want to go to the mixture property. List the available mixture property functions. Note that you have to have a mixture model defined in order to use these functions. You can define a mixture property but right-clicking the thermodynamic system node and selecting mixture property. Thermodynamic model section when a liquid is present, use the liquid phase model list to select the thermodynamic model for this phase. When a gas is present, use the gas phase model list to select the thermodynamic model for this phase. If both gas and liquid phases are available, the liquid phase model is set to an equation of state. Then the gas phase model is set to the same model automatically. Now I want to go through the property models, display the settings for the available individual property models. The property models can be changed by selecting different values from the combo box in the model column. For example, for gas thermal conductivity, you can select kinetic theory or read all from the corresponding combo box. You can also select the property model in the last step of thermodynamic system visual. By selecting the advanced option checkbox, see select thermodynamic model. Now I want to go to the binary interaction parameters. This section can be used to inspect and edit binary interaction parameters. Select a pair of species, first and second column, species 1 and species 2, as shown in figure 6-7 to edit the corresponding binary interaction parameter currently in use. In cases that the thermodynamic model has more than one type of binary interaction parameter, each type of the interaction parameter will be shown in a column in the table. Figure 6-7 illustrates entering the binary interaction parameter for the solved Redlich Quant model. When a binary interaction parameter is not available in the database for a pair of the species, the parameter value is set to 0 as a default. Modifying an existing system. It is possible to modify an existing thermodynamic system, for example, by changing the included species or phases. To do so, right-click the thermodynamic system node and select add or remove a species or define system from the context menu. Both of these options are available for the systems created using thermodynamic system. For a predefined system, the option add or remove a species is available for dry air and moist air. For a water steam system, neither of the two options are available. When the properties of a user-defined species have been changed, select update from the species for change to take effect in the thermodynamic system. Figure 6-8 illustrates modifying the species and phase of a thermodynamic system. Now I want to go to the add or remove a species. Selecting add or remove a species takes you to select a species step. In the thermodynamic system wizard, use the add species button to add a species to the selected species list. To remove a species, select it in the list and use the remove a species button. Make sure to click the finish button in order for change to take effect. Note that adding or removing a species in thermodynamic system that is currently coupled to a reaction engineering interface or chemistry interface breaks this coupling. See the coupling with a reaction engineering and chemistry interfaces for how to update this coupling. Now I want to go through the define system. Selecting define system takes you to select system step. In the thermodynamic system wizard, you can select the desired system from the list. Make sure to click the finish button in order to in order for change to the take effect. Note that changing the phases in the thermodynamic system that is currently coupled to a reaction engineering interface or chemistry interface breaks this coupling. See the coupling with the reaction engineering and chemistry interfaces section for how this coupling can be updated. Update from a species. This option is available in a thermodynamic system that includes the user-defined species. Use it to update the system following to a change in the species properties. Warning information. A sanity check is always performed when a thermodynamic system is created or if any problems are found. A warning information note listing the problem is added under the package. One example when this occurs is when a parameter required for the thermodynamic model, typically a binary interaction parameter, is not available in the database. Thank you so much for watching my tutorial video until the end. Today is 20th of May 2026. Time is 12:29 p.m. Also, you can download the proper and appropriate and related console file from github.com/masterscript.